In this chapter, we're gonna cover again joining processes. This time it is solid state welding process. In this chapter, we're gonna take a look at joining processes in which the parts welded do not undergo a phase change. We will start describing cold welding, followed by ultrasonic welding, then friction welding, resistance welding, explosion welding, diffusion bonding. All different types of solid state welding processes will be described. So in solid state welding, joining takes place without fusion at the interface of the two parts being welded. Therefore, unlike the fusion welding process we have learned in the previous chapter, in solid state welding there is no liquid or molten phase required for joining. We can explain solid state welding, the principle of it, as if two clean metal surfaces are brought into close contact with each other under sufficient pressure, they form a bond and produce a joint. So if we want to form a strong bond, therefore it is important to have these interfaces free of contaminants such as oxide films, residues, fluids, and adsorbed layers of gas, etc. So how does then the solid state bonding forms? There can be heat. Heat is provided to promote diffusion. Diffusion is basically the motion of atoms across the interface. So this is going to be diffusion bonding. Or friction. Heat may be generated by friction, or there can be an electrical resistance. And there is also pressure that can be applied together with the heat at certain cases. So the higher the contact pressure, the stronger is the interface. Examples are roll bonding. And there can be bonding induced with relative interfacial movements, and such as in ultrasonic welding. Cold welding is a process where the pressure is applied to the workpiece through dies and rolls. In this case, the joining happens through plastic deformation, so it is essential at least one of the material to be ductile. Therefore, it is usually performed on non-ferrous metals or soft iron. And it is important the surface to be clean prior to this process. Joining of two dissimilar metals, if they are mutually soluble in each other, if you remember from phase diagrams, there can be intermetallic compounds forming in the joint, which can make the joint weak and brittle. Therefore, an example to this is aluminum and steel bonding. So it is better to have two similar materials because the best bond strength will be obtained when we are joining two similar materials. In roll bonding, the pressure required for welding can be applied through a pair of rolls. It can be carried out elevated temperatures. We call it hot roll bonding. One application of roll welding includes cladding stainless steel for corrosion resistance. Here we are seeing the illustration of roll bonding or cladding. Examples can be a skin of high corrosion resistance, aluminum over a core of high-strength aluminum or conventional steel with a stainless steel cladding. In ultrasonic welding, it is two components are held together under clamping force and oscillatory shear stresses of ultrasonic frequency are applied to the interface to cause coalescence. Shearing stresses cause plastic deformation at the interface of the two components, breaking up oxide films, contaminants. This allows for good contact and produce a strong solid-state bond. This technique can be used with a wide variety of metallic and non-metallic materials, including dissimilar metals. It is extensively used for joining plastics. In friction welding, the heat required to produce the joint is generated by mechanical friction at the interface between a workpiece. One is moving and other one is stationary. The pressure at the interface and the resulting friction produce sufficient heat to develop a strong joint. The compression force upsets the parts and flash is produced. It can easily be removed by machining or grinding. This process is suitable for welding dissimilar metals with very different melting temperatures and physical properties such as copper to aluminum, titanium to copper, nickel alloys to steel. Here we are seeing the formation of flash on the fusion zone and as a function of axial force applied and the rotational speed. So you are seeing different types of flash is forming. In resistance welding, the heat required for welding is produced by electrical resistance across the two components to be joined. The advantages here is high quality welds. They don't require consumable electrodes, shielding gases or flux, and can be produced at high rates. In explosion welding, rapid coalescence of two metallic surfaces is caused by the energy of a detonated explosive. And it is commonly used to bond two dissimilar metals. So the high-speed collision causes the surfaces at the point of contact to become fluid, and any surface films like oxide layers are expelled forward from the surface. Here we are seeing the illustration of this process, the explosives and the clad metal and the base metal, and two different examples, two different systems, titanium and low carbon steel joined together, and iron nickel alloy joined with low carbon steel together in image C. So the contact pressures developed are very high, as you can imagine, and this the kinetic energy of the plate striking the mating component causes a wavy interface, as we are seeing in the images. And this kind of interface strengthens the bond because it is increasing the contact area and tends to mechanically interlock the two surfaces. Diffusion welding or diffusion bonding, both are correct, occurs when properly prepared surfaces are maintained in contact under sufficient pressure and time at elevated temperature. So there is plastic deformation that happens, but the principal bonding mechanism is atomic diffusion. Temperatures are well below the melting points of metals, like 0.5 times the melting temperatures. So, diffusion bonding is capable of joining a wide range of metal and ceramic materials as well as dissimilar material combinations, composite materials in both small and large sizes. Furnaces with an inert or protective atmosphere can be used to produce high quality joints of the reactive metals such as titanium, beryllium, zirconium, and high temperature refractory metals. So if we have same metals joining, the bonded interface will exactly the same. That will has the same physical and mechanical properties of the base metal. And the strength of the bond depends on, as you can imagine, the pressure, temperature, time of contact, and cleanliness of the surfaces are very important. And you might expect if different materials are joined, brittle intermetallic compounds can again form in this process. Diffusion welding is used for fabricating complex parts for aerospace, nuclear, and electronic industries. And here you see the application areas in aerospace applications for diffusion bonding. You see different types of parts were joined together using the diffusion bonding or diffusion welding technique. So in this chapter we have learned solid state welding processes. In the previous chapter we have learned oxy-fuel gas and arc welding techniques, and in this chapter we have learned solid state welding. And we talked about different types of techniques, and we talked about surface preparation and cleanness is especially important when it comes to solid state welding. Pressure can be applied mechanically or by explosives. Heat can be generated by electrical resistance or furnaces. It may be generated by friction as it is in friction welding.